Hi, everyone. In this walkthrough video, we're going to talk about a few hints for each problem in the problem set. The first problem asks us to find the lengths of zy and xy and answer each question. First, how would we describe this triangle? Well, notice the angles that we're given are 45 and 90. That means the third angle has to be 45 degrees. So we could describe it as a 45, 45, 90 triangle, or we could describe it as an isosceles right triangle. The next question is, which ratio should we use to solve for the missing side lengths? Well, anytime we have a 45, 45, 90 triangle, we use a 1:1 to root 2 ratio. 1:1 means the leg lengths are equal, and 1:1 to root 2 means that to get the hypotenuse length, we multiply the leg length by root 2. So we would write that as 1:1 to root 2. And we could type that out by using the math editor in Google Docs. Go to Insert Equation, and then you'll find the radical symbol here. So you can use that when you type out your answers. Okay, and then we're asked to find zy and xy. Well, we know that the hypotenuse length is equal to the leg length multiplied by root 2. So that means if we want the leg length, we can take the hypotenuse and divide by root 2. So I'm going to do this with you. 24 divided by root 2. Now, if you're thinking that you can simplify this, you are right. The way that we simplify this is by multiplying by root 2 over root 2, which is really just multiplying by 1. So we're not changing the value of the expression at all. And this gives us 24 root 2 over 2, because root 2 multiplied by root 2 is 2. Dividing the whole numbers, 24 and 2, gives us 12 root 2. And when you show your work, make sure that you show the process of finding the answer, 12 root 2, and then type those answers here. And when you do your typing, it's totally fine to delete the blanks as you go. Okay, let's look at this question. How would we describe this triangle? Well, it is half of an equilateral triangle. We could also describe it as a 30, 60, 90 triangle. So the ratio that we always use for a 30, 60, 90 triangle is 1 to root 3 to 2. And that means to go from the short leg to the long leg, we multiply the short leg length by root 3. And to go from the short leg to the hypotenuse, we multiply the short leg length by 2. Okay, so how do we find QR? Well, we're going to take 6 root 3 and multiply by root 3. So I'll do that with you. If I take 6 root 3, 6 root 3, and I multiply by root 3, that gives me 6 multiplied by 3, because root 3 multiplied by root 3 is just 3. So that's 18. And then when we multiply 6 root 3 by 2, we get the hypotenuse length. 6 root 3 multiplied by 2 is 12 root 3. So in your work, show how you find QR and PR by applying the 1 to root 3 to 2 ratio. All right, now we want to find the value of x. So I'm not going to be quite as helpful on this problem, but what I'll tell you is we have two 45, 45, 90 triangles. So first apply the 1:1 to root 2 ratio to figure out what the hypotenuse of the smaller 45, 45, 90 triangle has to be. You know, whatever this length is the same because the larger triangle is also 45, 45, 90. And then once you have the leg length of the larger 45, 45, 90 triangle, just multiply by root 2 again to get the hypotenuse length of the larger 45, 45, 90 triangle. So another way of thinking about this is you're multiplying by the square root of 2 twice. Once to get this hypotenuse, and then multiplying by root 2 again to get this hypotenuse. Now let's talk about finding the values of x and y. Well, right here, we have a 30, 60, 90 triangle, and we're given the hypotenuse. The hypotenuse is 18. To figure out x, what we're going to do, since it's a short leg, is divide by 2. So that means that x has to be 9. Now, this is a 45, 45, 90 triangle. So the other leg is also 9. But this is also the long leg of a 30, 60, 90 triangle. So if this is 9, to get the short leg of the 30, 60, 90 triangle, we're going to divide 9 by root 3. So review your notes and review the examples that we've done before to remember how it works when you divide 9 by the square root of 3. And I'll give you a hint. Start by multiplying by root 3 over root 3. And then whatever this length is, since this is a rectangle, this is the same length. Y is the same length as the short leg of this 30, 60, 90 triangle. Okay, now let's talk about number 5. All right, we want to find the values of x, y, w, and z. Let's see what I have here. Well, let's look at the 30, 60, 90 triangle on the right. We're given that the long leg is 4 root 3. So to get the short leg, we're going to divide by the square root of 3. 4 root 3 divided by the square root of 3 is just 4. So x is 4. And then to get w, we're going to multiply the short leg, x, by 2. All right, so now let's talk about how we can figure out the long leg of this larger 30, 60, 90 triangle. Well, we know that 4 root 3 multiplied by root 3 is going to give us the long leg. So you can just take 4 root 3 and multiply by the square root of 3. And then we know that the hypotenuse of this larger 30, 60, 90 triangle is going to be 4 root 3 multiplied by 2, because the relationship between the short leg and the hypotenuse of a 30, 60, 90 triangle is a factor of 2. And then you can also notice that this entire triangle is a 30, 60, 90 triangle because this is 90, this is 30, and this is 60. So once you find the lengths, make sure that your final answers make sense. This is just a nice way to check your work. All right, so we're showing our work here, typing our answers in here. Remember that you can delete these blanks. And then in problem 6, we are finding the altitude. We're told that the altitude of an equilateral triangle is 7 root 3, and we want to find the perimeter. So I'm going to sketch this triangle. Okay, so here's an equilateral triangle, and I highly recommend doing this in Sketchpad. So we know that this is 60, this is 60, this is 60. We know that the angles of an equilateral triangle are 60, 60, and 60. And then we know that when we draw an altitude, I can do a better job. When we draw the altitude of the equilateral triangle, it's going to split this side in half. In other words, these are congruent. So this is 90 degrees. This angle is bisected. So this is 30, this is 30. So in other words, this is a 30, 60, 90 triangle. We're getting two 30, 60, 90 triangles when we draw the altitude of the equilateral triangle. So, oops. This is 7 root 3, which means that this length right here has to be 7. I'm going to do that again. This is 7. And also, this is 7, because both of these are 30, 60, 90 triangles. So that means that the length, the side length of the equilateral triangle is 14. So the perimeter is going to be 14 plus 14 plus 14. Okay, and then this problem, we're asked to find the length of AE. And we're told that BD is 4. So we know that ABCD is a square. It's a square made up of 4 smaller squares. So since BD is 4, we can figure out what AD is by dividing 4 by the square root of 2. Because we know that the relationship between the diagonal of a square and the side length of a square is the same as the relationship between the hypotenuse and the leg of a 45, 45, 90 triangle. So we're going to take 4 and divide by root 2 to get AD. And then once we have AD, we can divide that by 2 to get AE. And to find the area of the square ABCD, we're going to we're going to figure out what AD is. And again, we do that by taking BD, which is 4, and dividing by the square root of 2. So we take AD and we multiply it by AB, which is also going to have the same length as AD because this is a square. So once you figure out what AD is, you automatically know what AB is. And the area of the square is going to be the length of AD multiplied by the length of AB. And one more time, we get the length of AD by taking BD, which is 4, and dividing by the square root of 2. Okay. Problems 8 and 9 are similarity review problems. So if you need a review of solving similar triangles, you can click these links here. If you ask for more guidance on solving these problems, like if I see that a lot of people are getting stuck, I can post another video to help you, to give you some guidance for these. But what I recommend is set up a proportion by figuring out which side lengths are corresponding. And notice, for example, in these two triangles, that these two sides are parallel. So you know that corresponding angles are congruent, which tells you that this angle is congruent to this angle. And you know that angle C is a shared angle. So these triangles are similar by angle-angle similarity. And it looks like you're trying to figure out the length of A prime, B prime. Well, you know that AB is 12, and you know that AB corresponds to A prime, B prime. You also know that you have a side length of 3 corresponding to a side length of 9. So that tells you that the scale factor relating the small triangle to the big triangle is 3. because this length is 3 and the whole length is 9. Okay? So show your work to figure out the length of A prime, B prime. And it looks like there's a mistake here. This should say A prime, B prime, C, not A prime, B prime, C prime. There we go. All right. And then to find the length of EF, well, first, notice that if you calculate the missing angle measure here, angle E, it's going to be 82 degrees. So these two triangles are also similar by angle-angle similarity. And then what you should do is figure out which sides are corresponding and set up a proportion. So you know that AC and DF are corresponding, and you know that BC and EF are corresponding, and you're trying to find EF. So you could say 14 over 21 equals 12 over X. Solve for X, and that's going to give you EF. So I'll just write that out to help you. The proportion that you're going to solve is 14 over 21 equals 12 over X. Solving this proportion tells us what EF is. And then finally, in this last problem, the only hint I want to give you is that if you look at the angles of both of these triangles, you will see that they are similar by angle-angle similarity. In this triangle, you're given both of the legs of the right triangle, and you're not given the hypotenuse. And in this right triangle, you're given the hypotenuse and you're given one of the legs. So you think about scale factor, think about similarity, and think about whether you really need to use the Pythagorean theorem to answer this problem, to answer this question. And you're showing your work here. All right, that's the end of the walkthrough video. If you have more questions, please type your questions in a comment, and I will look at your questions and either help you directly, or if many people have the same question, I'll post another walkthrough video.